Beneath eastern California, a vast reservoir of magma is shifting, and scientists are on high alert. New satellite data has revealed a significant movement of molten rock beneath the Long Valley Caldera, one of North America's most dangerous volcanic systems. This isn't Hollywood fiction, it's real, measured in millimeters of ground deformation from space. The findings show the caldera is more active than previously believed, forcing a re-evaluation of volcanic hazards in the region. For decades, Long Valley has been monitored, but these new observations mark a turning point in our understanding. The ground is rising and falling as magma migrates below, signaling that the system is evolving. This isn't a prediction of imminent eruption, but it's a clear sign that vigilance is needed. The silent movement of magma is a quiet alarm, one that scientists and the public must heed. The world is watching as California's sleeping giant stirs. Long Valley Caldera, near Mammoth Lakes, is the remnant of a super eruption that occurred 760,000 years ago, one of the most powerful in Earth's history. The ancient blast blanketed the western US in ash, and today, the caldera remains a top priority for monitoring by the US Geological Survey. The region is a major tourist destination, with the town of Mammoth Lakes sitting on the caldera's rim, placing thousands at risk. Long Valley's ongoing activity, including earthquake swarms and ground uplift, makes it a natural laboratory for scientists. By studying it, researchers refine models of magma storage and movement, improving eruption forecasting worldwide. Any new information about magma movement is treated with utmost seriousness. The caldera's destructive history and present-day activity are constant reminders of its potential. A dense network of sensors tracks seismicity, ground deformation, and gas emissions. Recent satellite data adds a crucial layer, offering a detailed picture of the forces at play. Sustained scientific vigilance is essential in this beautiful but hazardous region. To understand Long Valley, you need to know what a caldera is. A vast depression formed when a massive eruption empties a magma chamber, causing the ground to collapse. Calderas are the sites of Earth's most powerful eruptions, or supervolcanoes, capable of global impact. These eruptions eject enormous volumes of ash and rock, altering climate for years. After the initial blast, the system remains active for millennia, with uplift, earthquakes, and smaller eruptions. Long Valley is a textbook example. A 20 by 10 mile depression formed 760,000 years ago, with ongoing activity since. The resurgent dome in its center is a key focus, as its movement signals changes in the magma reservoir. Caldera eruptions are rare, but civilization-altering. The main danger is not lava, but ash that can disrupt entire continents. Monitoring active calderas like Long Valley is vital for global risk assessment. Today's subtle unrest offers a glimpse into the powerful forces beneath our feet. Detecting magma movement from space has revolutionized volcanology, thanks to interferometric synthetic aperture radar, or INSAR. Satellites send radar pulses to the ground, then compare images over time to detect tiny changes in surface elevation. These changes, measured in millimeters, create colorful interferograms that reveal ground movement. Upward bulges signal magma accumulation, while sinking suggests deflation. INSAR provides a comprehensive map of deformation across vast areas, far beyond what ground sensors can achieve. At Long Valley, INSAR has tracked inflation and deflation for decades, establishing a baseline for normal behavior. Any deviation from this baseline is quickly detected, making it a critical tool for early warning. The latest findings are a direct result of this persistent, high-precision surveillance. Satellites are our remote eyes, offering crucial data on the restless volcanic system. This technology allows scientists to model the size, depth, and movement of magma with unprecedented detail. INSAR's wide coverage and precision are transforming how we monitor volcanoes worldwide. Recent satellite data has uncovered a significant, previously unseen pattern of magma movement beneath Long Valley. From 2020 to 2025, INSAR shows uplift in a new area southeast of the resurgent dome, with subsidence on the opposite side, evidence of lateral magma migration. Scientists estimate several cubic kilometers of molten rock have shifted horizontally within the reservoir. This isn't the usual vertical breathing, but a dynamic redistribution, confirmed by multiple datasets. The new uplift is closer to regional faults, raising concerns about future pathways for magma. While there's no sign of magma moving toward the surface, this shift marks a fundamental change in the system's behavior. The discovery resets our understanding of Long Valley and highlights the need for continuous, advanced monitoring. The lateral magma shift at Long Valley is a major concern for several reasons. First, it's a clear departure from the volcano's long-term behavior, signaling a new phase of activity. Such changes can destabilize the region, increasing the risk of earthquakes as pressure is redistributed and new fractures form. The volume of magma involved, several cubic kilometers, suggests a powerful driving force, possibly an influx of deeper, hotter magma. The new uplift is near the Caldera's structurally weak southern boundary, an area with a history of intense earthquake swarms. This proximity raises the risk of magma finding new pathways to the surface. Scientists are deploying more monitoring equipment to track these changes in detail. The magma movement is not just a scientific curiosity, it has real implications for hazard assessment. Understanding what's driving this shift is key to forecasting future risks. Long Valley is one of about 24 supervolcanoes worldwide, including Yellowstone in the US, Campi Flegrei in Italy, and Taupo in New Zealand. These systems share signs of unrest, ground deformation, earthquake swarms, and ongoing magmatic activity. Monitoring at places like Yellowstone and Campi Flegrei provides valuable comparisons for interpreting Long Valley signals. Each caldera has unique behaviors, but all pose high-impact, low-frequency risks. The newly detected lateral magma movement at Long Valley is scientifically intriguing and may represent a less understood mode of behavior. Global collaboration among volcanologists helps improve forecasting and hazard assessment for all these systems. Advances at one caldera inform our understanding of others. The global perspective underscores how much we still have to learn about these sleeping giants. Every new discovery adds to our ability to interpret their subtle warnings. The recent findings at Long Valley do not indicate an imminent eruption. The USGS alert level remains at its lowest. However, the new data has prompted a re-evaluation of long-term hazards, especially the risk of earthquake swarms triggered by magma movement. Most quakes would be minor, but stronger ones could cause local damage and alarm, particularly in mammoth lakes. Another hazard is hydrothermal explosions, sudden blasts of steam and rock that can occur with little warning. The magma shift also forces planners to update hazard maps, evacuation routes, and emergency plans. Collaboration between scientists and emergency managers is key to robust response strategies. Public outreach helps residents understand the risks without panic. The probability of a massive eruption remains low, but smaller events are a realistic concern. The new data is a crucial input for ongoing risk assessment and preparedness. The goals stay ready for the likely, while never ignoring the possible. The detection of a lateral magma shift beneath Long Valley marks a pivotal moment in volcano monitoring. Advanced satellite technology has revealed a dynamic, evolving system beneath our feet. This isn't a forecast of disaster, but a discovery that sharpens our focus and deepens our understanding. The main concerns: increased seismic activity, new pathways for magma, and a shift in the volcano's baseline behavior. The data from Long Valley informs global strategies for monitoring and preparedness. The challenge is turning complex scientific data into clear, actionable information for public safety. As our ability to see inside the Earth grows, so does our responsibility to translate these discoveries into effective protection for communities.